So as we had before, remember from our previous class, we managed to work with the part that we can refer to the modulus and also the argument, which is a continuation that we are going to actually have on the conversion from the rectangular form or the standard form into the polar form. So it's actually a continuation that you're now having. And with that conversion, I want us to consider first, what is it that we consider as a rectangular form? Remember, in rectangular form or the standard form, this is the one that I said a complex number Z can be given in the form of A plus or minus JB, like that. Meaning to say it can be a plus, it can be a minus, whatever that you're given. That's the presentation of a rectangular form, which is our standard form. But there is a format again that we can consider, which is the polar form. That's another format that you can have, where now a complex number Z is given in the form of R angle of theta. So if we consider from the previous class that we had, we considered this R, we also considered the theta, the modulus, and our argument. So that was the purpose of that class. That is the calculation of this modulus and also to find argument. So meaning to say, if you are given a complex number that is in rectangular form and you are being asked to convert that to polar form, this is how you are supposed to present. So it can be presented in this form, which also depending with also the textbook that you're using, some textbooks, they can present this in the form of R that is in place of this angle. They can use this cis theta like that. So we can use that, R cis theta. What is important is, what is that we need? The modulus and argument. As you calculated, so we're not going to waste much time on that because we had a class. So I need us to work on that class. Calculation of these. Remember, if you are given in rectangular form, I talked about this from the Argand diagrams. Just consider the recap where you've got your real axis and imaginary axis you've presented. Maybe it is in the first quadrant, depending with what you're given. This is your A, this is your B, this is your theta, and this is your R. So depending with the quadrant, that is in terms of the angle theta. All right, but in the calculation of the modulus, which is our R, this part is not affected. Remember, we calculated this. So remember from our class, we said R is equal to the square root of, we obtained the square root of A squared plus B squared. So this is a continuation from that. And as I said, from the theta that we have, which is the argument, the first thing that you're supposed to do in order for you to determine argument. First thing is to calculate acute angle. So for theta, which is our argument, first calculate. So in this case, you're going to calculate the alpha, which is representing the acute angle. First calculate the acute angle, which is also, like I said, this acute angle. You can also refer to this as the reference angle. So this is our reference angle. After calculating the alpha, which is your acute angle, and now you can determine your theta, depending with the quadrant. Depending with the quadrant. So just as a summary of what we had before, remember it's considered in the first quadrant, second, third, and the fourth quadrant, and also considering positive and negative angles. But in this case, I'm just going to list the positive angles. Remember, if you are having the first quadrant, if this is alpha, your theta is going to be equal to alpha. We also concluded in the second quadrant that our theta is going to be 180 degrees minus alpha. And we also concluded that in the third quadrant, if you're given this, your theta is going to be 180 degrees plus alpha. And also in the fourth quadrant, your theta is going to be 360 degrees minus what? Minus alpha, considering the positive angles. So you first calculate your alpha, then determine the theta according to the quadrant. All right, so then determine theta, which is our argument, according to the quadrant. According to the quadrant. So meaning to say, it is best that whenever you are given to express in polar form, it is best that you do present the Argand diagram so that you know in which quadrant exactly am I going to have the theta. Because if you do not present that, how are you going to tell which quadrant? It is not just having this alpha, no. Okay, by the way, how do we obtain this alpha? Remember from our calculations, I said that alpha is being taken from arctan opposite over adjacent. All right, remember our alpha is equivalent to arctan opposite over adjacent, B over A. So you have this. You also have the alpha, the acute angle. Then determine the exact angle, which is your theta, which is the argument. So I'm just going to list one or two examples that we can have. And it depends with the question. Like I said, when it is about theta, remember we had negative angles. Make sure that you refer to the class that of the argument and the modulus and the argument, because you'll be given in an exam, specifically they're going to mention maybe in terms of the angles, or they will specify. If they do not specify, it is you who is going to determine the theta that you want, because theta, which is our argument in this case, remember, it can be positive, it can be negative. So we are supposed to be careful on that one. All right, so let us just say we are given questions like to convert the following. So we're just going to have a few examples in that case. Convert the following complex numbers. Convert the following complex numbers into polar form. Into polar form. So if you are given just a statement like this, it means you are supposed to obtain this format. Remember, your polar form. But it is now us we're supposed to choose the theta to use. So in this case, we are going to refer to theta as positive angles. So I'm going to have this to express theta as positive angles. So in this case, we're going to express our theta, which is our theta represents what? That is the argument. So we're going to have this theta, or our argument, as a positive. So meaning to say, if I am to consider this as a positive angle, I'm now limited to this presentation here. So for this class, we are going to be limited to the positive angles. These are our positive angles. All right, so let us see our examples. Number one, let us just say we are given to convert. Like I said, we need to convert to polar form. And you are given Z, a complex number, which is equal to 5 plus J8. All right, let's say this is what we have. The first thing, try by all means to present the Argand diagram, because the Argand diagram, it helps us to locate the theta now. The theta, so meaning to say, what are we having? This is real, this remember? imaginary part is also positive. So on our argand diagram, remember I said this will be your real axis and this will be your imaginary axis. So just gonna need these values, you're not gonna need like 1, 2, 3, 4, guys. The real is 5. So let's say, remember this is positive, negative. So the real is 5. Let's say 5 is somewhere there. Let's say this is where we have our 5. Imaginary is positive. That is J8. Let's say this is where we have our J8. It's positive. So where these two meet, remember, now take this 5 going up, the 8 going this side. Where do they meet from the origin? We're going to have this presentation. So the presentation here, guys, do not even worry about this. It is just telling us where are we working with? Which quadrant are you working with? In. That is the presentation. Do not worry about that. That is where these angles now play a role. The issue of the quadrants. That is where it plays a role. Because what is it that you have in this case? It is the alpha that you're going to present. And this is our R. Remember, like I said, you're supposed to calculate alpha first, acute angle, the reference angle, before calculating or determining theta, which is our argument, before determining the argument. Before you talk of the argument, you first find its acute angle. All right. So let's just be quick about this one. How do we calculate R? Because R is easier. Remember that R is equal to, so this is our solution. Remember, R is equal to the square root of A squared plus B squared, meaning to say R is equal to the square root of A and B. Remember, this is part of A, this is part of B, where A is the number that you're given there, the 5, and the B is the 8, the number that we have. Or you can just take it here, guys. Remember, your presentation A plus or minus JB. So A and B. This is your A, this is your B. So A squared, that is 5 squared, plus B squared, which is 8 squared. So what are you going to have? Can use this, can use a calculator to present this. So what are we going to have at the end? All right, so quickly, guys, remember we had 5 and 8. Square root of 5 squared plus 8 squared, like this. So this is going to be square root of 89. You can write it like that. Or you can write it as a decimal. 9,4, you can even, let us round to 3 decimal place, shift, go to the setup, then fix to 3 decimal place, just press 3. That's 9,434. Okay, 9,434, 3 decimal places. You can just use any, depending with the instruction of the question paper, if you are now in exam. Let's talk about alpha. We saw that from our formulas, alpha, it can be calculated from arctan, opposite over the adjacent, arctan B over A. This is alpha, not theta. So B, that's 8. A, that is 5. Opposite. B over A. Number this B over 8. Like I said, it's only that these numbers are positive. If any of these numbers was a negative, ignore that. Ignore it. Just use the number as positive as it is. Ignore the negative sign. Ignore it. Because that part is already analyzed in the quadrants. So you ignore that. So what is our alpha? Acute angle. We need this from our calculator again. So this is what you're going to have. So this is arctan shift tan 8 over 5. This is what you're going to have. 57.995 to 3 decimal places. Remember, we already fixed our calculator. So that's 57.995 degrees. As your what? As your alpha, which is the acute angle. So it is only that in this first quadrant, we do not notice we do not notice the importance of this. Do not worry. You're going to understand me in another example. You do not notice that because it's the first quadrant. So even if you make a mistake, you just use this theta, this and that. You will never notice that. Okay, anyways, let's move on. We said we are going to need theta, which is the argument according to the quadrants. And they specify that our theta is supposed to be taken as what? As positive, as a positive angle. So as a positive angle, which quadrant are you going to apply? We are in the first quadrant, remember. So we conclude now from this to say in the first quadrant, theta is equal to what? Theta is equal to alpha. We are talking of what? The exact angle theta. It is equal to alpha. We're in the first quadrant. So that's where I said in this first quadrant, you do not see the effect of this. So theta is equal to alpha in the first quadrant. So therefore, our theta is going to be what? 57,995 degrees as it is. There is no effect in the first quadrant. There is no effect at all. It's the first quadrant. So therefore, we can conclude that this set in polar form that we had in polar form, Z can be given as what? R in the angle of theta. Do not forget the format. Or we can write this as R cis theta, depending, like I said, the textbook that you're using. So we have it. R, our modulus, 9,434. Angle theta, our argument, 57,995 degrees. We have this in what? In polar form. A rectangular to polar form. So we're going to notice in another class the vice versa of this. All right. So like I said, this example that we had, it is not that effective because of the quadrant where we are in. We are talking of the first quadrant where alpha and theta are the same. So we do not notice like the effect of that. Let's consider this other example. Let us say we are given again to convert the following complex numbers into polar form. Okay, we are given Z is equal to 3 minus J4. This is what we have. 3 minus J4. You need to convert this to polar form. Remember, to polar. And I said the first thing, present Gantt diagram. Try and have that. So do not worry about many numbers, just like, okay, this is the real, this is the imaginary. Where is it that I'm considering? The real A, the part of A is positive. Where is it positive? This side, the right side. So you just mark there, maybe this is where you have your 3. The imaginary is what? Negative. So where do we find our negative? Down there. So just indicate a point, just indicate maybe minus J4. You can have your numbers, you guys, minus J1. It's not like it's important. You just need to notice like which quadrant is it, guys. So the part of the J is a negative. The real positive. Where is it? The real positive, imaginary. If you understand that, do not even worry to present, to say, I have to be accurate this point. No. What you just need to is that the real is positive, the imaginary is negative. So if you understand it that way, you can lessen up your work. You can lessen up your work because one, you do understand the quadrants where it is going to be. You understand your quadrants. If you understand these quadrants to say, if my angle is in the first quadrant, my answer is going to be that alpha. In the second quadrant, 180 minus. If you understand that, guys, it is going to be easier now. It's going to be easier for us. Because what is that I just need to note? I just need to note, okay, this is the real. This is how another way that you can work with it. This is real. The real is positive this side. And it is negative this side, on the left side of it. Talking of the imaginary, it is positive going up. And it is negative down, just like the y-axis. So when you know this, you just ask yourself to say, okay, according to this is our real, and this part, our imaginary. The real is positive, imaginary, negative. Where is it that we have both happening like this? Real, positive, imaginary, negative. Which quadrant is it? It's going to lie in this quadrant. Meaning to say your answer is going to lie in the fourth quadrant. Knowing that your answer is going to lie in the fourth quadrant helps you now to determine your angle theta. There's no need for you to even draw that. You just need to know, okay, it's going to lie there. Just present. There's no need for you guys to, all right, this is minus J4. Where are they going to meet? I'm going to have this angle. This is my alpha. Then the angle that I'm referring as theta is going to be this one. And this theta is, it's exam. A lot of time. You're taking a lot of time. If you understand that, okay, you just go there and you have your solution. What is that I need in polar form? Z is supposed to be equal to R angle of theta, where R is equal to what? Remember, square root of A squared plus B squared. Where A and B are given here, this is my A. And what is my B? The part that is affecting J, which is minus 4. So in this case, you're considering your B as a negative 4. But do not worry about this on the substitution, the negative there. Do not even worry, because the moment you square that, it becomes a positive. Okay, so this was supposed to be 3 squared plus minus 4 squared, which you can just write as 4 squared. There's no effect, or you can just write as minus 4 squared. Remember, guys, if you square a negative to be a positive, so there's no effect there. So your R there was going to give you a 5. You have that. You calculate your alpha because you know your formulas. What is the value for alpha? Which is acute angle. That is arctan. Arctan of what? Opposite over adjacent. B over A. Which I said in the calculation, you consider your values as positive. Do not worry about that negative. Just take as positive. That is 4 over A, which is 3. Ignore negative. You have to ignore that negative. You determine your alpha, which is your acute angle now. So by determining the alpha, which is representing our acute angle, remember the negative there is not considered. You ignore it, that one. So you're going to obtain something like 53,13 degrees, which is our alpha, this part of our alpha here. This is where we are. And we are in the fourth quadrant. So even without understanding this, just knowing what is the presentation of the fourth quadrant, you can determine your theta. Because you are told that it is supposed to be a positive angle, meaning to say we are considering this a positive angle. Remember, we said theta is equal to what? 360 degrees minus alpha in the fourth quadrant. So as a positive angle, therefore our theta was going to be 360 degrees minus the alpha that we calculated, 53,13 degrees. We are now having the exact angle, which is our argument. The exact angle now. So this was going to give us 306,87 degrees, which is our theta argument. If it was to say we are given that our argument or theta is supposed to be a negative angle, let's say that was our quiescent. How are you going to take this? Okay, on the class of the modulus and argument, I explained that in the fourth quadrant, theta is equal to minus alpha for negative angles. So if they wanted you to write as a negative angle, your theta was going to be equal to minus alpha. This is your alpha, minus 53.13 degrees, which is one and the same thing as this one. Only that this one is a positive angle. This one is a negative angle. They are both in the fourth quadrant, same quadrant, presented differently. One being positive, another being negative. But because we are told it is supposed to be positive, so therefore, we are going to conclude that in polar form, which we are supposed to have this as our angle of theta, our z is going to be equal to, we calculated r there, which is 5. The angle, a positive one, is what? That is 306.87 degrees, according to the positive angle. So questions can be like that, where they need you to present. So it depends with the quadrant. Like I said, everything conclude with the quadrant here. Everything that you're going to calculate for positive angles, Remember, this is for all positive angles within the 0 to 360. You conclude with the quadrant. Maybe it is going to lie in the third quadrant. Whatever that you're going to have there, conclude with the quadrant. So even without the diagram, this is what I was trying to say, if you are given this, there's no need for you to present like on the quadrant, like to actually present everything. You can just tell from what you're given to say, let's say you are given a z which is equal to, and you're given -3, and this is minus j4. Let's say this is what you have. You just have to figure out the real part. How is it? It's a negative. This is our real part. The imaginary part is also a negative. So on our diagram, where is it that the real is negative? Where is it that the imaginary is negative? We just need to notice that. Where is it? Remember, this is positive, imaginary, negative, imaginary. Positive, real, negative, real. Where is it that the real is negative? Imaginary is also, where is it? We can see that negative, it's here. So your answer lies where? In the third quadrant. And you know that in the third quadrant, this is how I write my answer. The exact value of theta, because r is not affected. R is not affected, your modulus. It is only the argument theta thereafter which is affected. You just have to tell. You are given, maybe it's -3 plus j4. Negative real, positive imaginary. Where is it? Negative real, positive imaginary. In the second quadrant, you know that, okay, my answer is going to be like this. So this is what you just need. All right, so this one, we just need to do as many questions so that it can help to understand, like in the presentation of how questions sometimes are given. What if we are given something like this one, where another example can be just maybe z is equal to 0 plus j9 like this, or they can just give you like z is equal to j9, where the real part is a 0. The real part is a 0. Okay, in the presentation, like we can say, okay, where is it where we have a 0? This is our imaginary, this is our real. Remember, even on the presentation of the Gantt diagram, we had numbers like that, where I said the real part, there's nothing to talk about the real part. So you focus on the imaginary part. There's nothing on the real. It's at 0 there. There's nothing. So it means it was supposed to be here, J9, somewhere there. It's a straight line going up like this. So since theta, which is our argument, like I said, it is taken from the positive horizontal axis. You're going to see that from the positive horizontal axis going this side up to this J9 boss, it's on a straight line. Vertically, that is where it is. Horizontally from the real axis. So this is direct at what? 90 degrees. It's direct at 90 degrees. What about our R? Our R is direct. The distance moved from 0 there direct to 9 there. That is going to be our R. Because we do not have a triangle where we can show that this is our R, this is our theta. So in that case, our R was the distance direct up to 9 there. That is your R. And your theta is at 90 degrees. You can just tell from the diagram when it is like that. So therefore, in polar form, our Z was going to be equal to what? 9, which is our R. Remember, we need R angle theta. Angle of what? Of theta, which is 90 degrees. But let's say we wanted to do calculations, because if you are using a calculator, you will notice something there. I want you to see something. Let's say we take this. Remember, our R is equal to the square root of A squared plus B squared. This one, there was no effect. We're just going to substitute on your calculator as it is. Your A and your B. Your A is what? That's 0 squared plus B squared, which is 9 squared. On your calculator, your R was going to be 9, direct as it is. But if you check now for the theta, remember the theta, the first thing is to calculate alpha, which is what? Acute angle. And you wanted to calculate that and you use arctan. Remember your formula, B over A. If you want to use this formula, arctan, B over A. What is our B? That is 9. Over what? Over A. What is A? A, that's a 0 like this. Because that is what you are being given by the formula. The formula is telling you this. But I want us to see from the calculator what was going to happen. All right. Let us have our calculator. So if you check on our calculator, this is shift tan opposite, which is 9 over what? Over a 0 like this. Calculator is giving us what? Math error, to show that this does not exist mathematically in presentation. To have this way, does not exist mathematically. So you're going to answer this question with the idea of what is happening on the presentation of the Argand diagram now. To say J9, it's a straight vertical. So the angle is 90 degrees. It's a straight vertical that we have. So if it was a condition that it was a negative, what was going to happen? Let's say it was a condition that was a negative. What was going to happen? You are given this as Z is equal to 0 minus J9. This is what we have. On the presentation, you are going to have this. This is your imaginary, this is your real, and this is your imaginary. We do not have anything on the real, but the imaginary is the one that is given imaginary. The minus J9, minus J9. There's nothing there in the real, it's a 0. So minus J9, our line is straight to minus J, straight there to minus J9. That is where it is. There's nothing to talk about the real. There's nothing. So just like before, our arrow was going to be what? The distance that we are simply moving from here to here. Remember, this is modulus, positive, always positive. We do not write negative answers, positive answers. Then what about the argument theta from this? Because we saw that arctan of this over there is going to be math error. Does not exist mathematically. As a positive angle from the positive horizontal axis from always. Remember, I talked about this argument. It is taken from the positive horizontal axis. Going in the anti-clockwise, because we're talking of the positive angle for this one. Which angle are you talking about? This one. That's a straight 207. Remember, this is 0, 90, 180, 270 degrees, and we are back to 360. So this is a straight 270 degrees. As a positive angle. If it was as a negative angle, it means we're going to take this one, minus 90 degrees as a negative angle. But you're talking of a positive angle for now. So therefore, in polar form, you are going to have your Z as R, which is 9, the angle 270 degrees. So your calculator is not always there for you guys. Analyze also from the presentation. Analyze from there, because questions, when it is like this now, it will be limiting you now to the proper understanding of what you're given. And also sometimes you'll be given a condition like, okay, these ones were a condition where the real part is a 0. It can be a condition where this time it is the imaginary, which is a 0. You're just given a real term. Remember, we had that from the modulus and argument class, where we saw that the imaginary can be just a 0. You are given Z is equal to 3 plus J0 like this. There's nothing to talk about. There's nothing to talk about the imaginary. There's nothing. This is what we have. And you want to write this in what? In polar form. Into polar form. What were you going to do? Okay, let's go back to our presentation. Because we do not have anything about the imaginary. There's nothing to talk about imaginary. It's at 0. J0, there's nothing. So what is it that we have? We only have the real. So you represent straight what you're given. You do not have the imaginary, just like what we had before. You were not having the real part. You were representing straight to the imaginary, straight to the imaginary. This time, you do not have that imaginary. It's a 0. So you go straight to the real. Where is it a 3? Positive. Maybe this is where we are. So that is what we're going to have. Straight at 3, because we do not have imaginary. So that is what we're going to have. Let's analyze from our diagram what was going to be our R, because Z in polar form must be in the form of R theta. What was going to be our R? The modulus, the distance from the origin up to 3. So our R was going to be 3. What about the angle? Remember the angle, it is that angle that is taken from the positive horizontal axis. So if I was going in the anti-clockwise, where I was going to move up to it, it's already in the, it's already lying, this line, it already lies in the real axis. So what is the angle there? It's 0 degrees. It lies along the line. So it is lying at what? At 0 degrees. So the angle thereafter was going to be 0 degrees. All right. Let's try our calculator this time and see if it was going to simplify this. Because last time we saw that for the angle, it was undefined. Let's try this time. Okay, remember our R is straightforward, guys. R is equal square root of A squared plus B squared. So r was going to be the square root of a squared. This is our a, this is our b, remember? So that's 3 squared plus 0 squared. So r was going to give us a 3 from your calculator. You move on to alpha, which is the acute angle, which was going to be arctan from our formulas. We said this is arctan b over a. So alpha, the acute angle, arctan b, what is our b? That's a 0 there. Over a is 3. So let's try and see this time what was going to happen with tan, arctan of 0 over 3. So this can be simplified. Okay, so this is arctan like this. That's a 0 over a 3, which just simply means a 0 there. So it was going to, all right, remember this fixing is because of fixed the calculators. Let me go back to the normal mode. So as you can see, that's a 0 there. Alpha is 0 degrees. And which quadrant are we talking about? The first quadrant. In the first quadrant, theta is equal to alpha. Theta is equal to alpha. So if theta is equal to alpha, therefore theta is equal to 0 degrees. So that's our theta. Just like that. All right, so that's how it can be like. What if it was a negative real term? We just want to use same numbers. Let's just have a negative. Another question, into polar form again. But we just need a condition where this one is a negative this time. What was going to happen? What was going to happen if this was a negative this time? This is what we have now as our question. We want to convert this to polar form. Okay, let's start by the diagram first. Analyzing the diagram, you are going to notice that this is our real, this is the imaginary. The real is negative. We're talking of negative 3 because there's nothing about, remember I said, if the imaginary is not there, guys, don't worry about that. Go straight to where the number is in the real. There's nothing about the imaginary. It's not there. There's a 0 there. It's not, it's not there. Straight at -3, maybe somewhere there. Because the imaginary, there's nothing there. So it was going to be a straight line like this from 0 to -3. So analyzing, we can see that our R is what? 3, the distance. It's a modulus, positive. The modulus is taken as a positive value. So the distance, positive, which is 3 units from 0 to -3. You take it as a positive. Cannot be negative. Distance is taken as positive. What about theta, the argument? Theta. How are you going to take your theta? You analyze now. This is where we are here, straight here. The line is here straight. It is, guys, the line is lying straight in this line, straight in this. What is the angle there? Remember, 0 degrees, 90 degrees, 180 degrees. We are at what? 180 degrees straight. We can analyze that. Or you could have obtained from the calculator, your R from the calculator, the square root of a squared plus b squared. So our R is the square root of a. This is our a. This is our b. What is our a? -3. -3 squared plus our b, that's what? That's 0 squared. You use your calculator there, you're going to get a 3. You talk of what? Alpha. The acute angle. Alpha is equal to arctan b over a. Alpha is equal to arctan b over a. 0 over a, which is 3. Like I said, do not consider the sign. Ignore the negative sign. So it's arctan 0, which was going to give us 0 degrees. But which quadrant are we talking about? We are talking about the second here, which we can talk of third or second, but this is second quadrant. Where in the second quadrant, theta is equal to 180 degrees minus alpha. So theta was going to be 180 degrees minus alpha. What is our alpha? Our alpha is 0 degrees. So 180 minus 0 degrees is what? It's 180 degrees. As you can see, it was going to be the same answer. So therefore, in polar form, our Z was going to be what? R angle of theta. 3 angle of theta. What is our theta? 180 degrees. Just like that. So we just need to work with more questions that can help to revise our conversion rectangular to polar form in that manner.